Have you ever stood near a harbor, watched a giant cargo ship or a luxury cruise liner, and noticed one curious detail? Almost every large vessel in the world has its lower section, just beneath the waterline, painted in a deep red color. It creates a strong visual contrast. But have you ever wondered why? Is it meant to frighten sea creatures? Could it be some kind of underwater camouflage? Or maybe it serves as a warning signal. The reality is far more interesting, and it has nothing to do with appearance. The answer lies in a fascinating blend of ancient maritime challenges, smart chemical solutions, and a long-standing respect for tradition. Today, we're going beneath the surface to uncover the real reason why ships across the world have red bottoms. To truly understand this, we need to travel back several centuries, to the era when ships were made entirely of wood. During those times, ocean voyages were slow, risky, and often unpredictable. A wooden ship moving through water became an easy target for marine life. The moment it entered the sea, it started attracting organisms like algae, seaweed, barnacles, and a destructive creature known as the shipworm. Despite its name, the shipworm isn't actually a worm. It's a type of mollusk that bores into wood and feeds on it. Over time, it could seriously damage the structure of a ship. This entire process of organisms attaching themselves to the hull is known as biofouling. At first glance, a few barnacles may not seem like a serious problem. But in reality, biofouling was a major issue. It added significant weight to the vessel and created resistance in the water, slowing the ship down dramatically. In some cases, ships could lose up to 50% of their speed and maneuverability. Back then, speed wasn't just about convenience. It could mean the difference between survival and disaster. Whether it was escaping enemy ships or completing trade routes quickly, sailors needed their vessels to remain fast and efficient. By the late 18th century, shipbuilders discovered an effective solution. They began covering the bottoms of wooden ships with thin sheets of copper. This worked because copper naturally acts as a biocide, meaning it prevents the growth of marine organisms. When copper interacts with seawater, it creates an environment that is toxic for sea life. Barnacles couldn't attach themselves, and shipworms couldn't penetrate the wood. As a result, ships remained cleaner, lighter, and much faster. However, things changed with the arrival of the Industrial Revolution. Wooden ships were gradually replaced by iron and steel vessels. But there was a problem. Copper sheets couldn't be used directly on iron hulls. When copper and iron come into contact in salt water, they create an electrochemical reaction, which causes rapid corrosion of the metal. To solve this issue, scientists and engineers developed a new solution: anti-fouling paint. Instead of attaching copper sheets, they created special coatings that could be applied directly to the hull. The key ingredient in these paints was copper oxide. And here's the interesting part. Copper oxide naturally has a reddish, rusty color. So the iconic red bottom of ships wasn't chosen for style or design. It was simply the natural color of the chemical coating that protected the ship from marine growth. Now, fast forward to the modern era. Today, technology has advanced far beyond those early methods. We now have highly advanced anti-fouling paints that are environmentally friendly and can be produced in almost any color imaginable. Ships could easily be painted blue, green, black, or any other shade. So why do most ships still use red? Part of the reason lies in tradition. The maritime world is deeply rooted in history, and sailors often respect long-standing practices. Over time, the red hull has become a recognizable symbol of ships across the globe. But there's also a practical advantage. The strong contrast between the red bottom and the upper part of the ship creates a clear visual boundary. This makes it easier for crew members to observe how deeply the ship is sitting in the water.